Hello, I am here doing the Calc BC and AB FRQ 1 for the 2023 exam. So it reads as follows. A customer at a gas station is pumping gasoline into a tank. Rate of flow of gasoline is modeled by a differentiable function f, where f is measured in gallons per second and t is measured in seconds since the pumping began. And so we have a table of f of t and t seconds. And we're going to interpret, using the context of this problem, what this integral is. And then we're going to use a right-Riemann sum to approximate this value. All right, so I'm going to start off by just writing the integral and kind of rephrasing this and saying the integral from 60 to 135 f of t dt, and then I'm just going to type out the rest of the systems. So this is adding up the rates of gallons per second. And so when you integrate a rate, you get a total. So this is the total amount of gas in gallons, because we're just going to try to be as specific as possible. That is pumped, let's see here, pumped into the tank of gas between T equals 60 and T equals 135 seconds. And then I'm going to add, since let's see, can I actually edit this and fix my spelling? And so that is, I was about to say that is part A. And so this is going to be equal to, and then we're going to approximate this with a right Riemann sum. So we're going to first look at, uh, it goes from 60 to 90 is this first interval, 60 to 90. And this is, we're going to use this height of 0.15. And so this distance is going to be 90 minus 60, 90 minus 60 times 0.15, because we're doing it from the right side. And then we're going to add this with 120 minus 90, 120 minus 90 times the 120, which is 0.01. We put 1.5, this is supposed to be 0.15. And then this is going to be 0.1. And I'm going to add that to 135 minus 120. So plus 135 minus 120 times 0.05. And this is in gallons. All right, part B asks if there's a value such that f prime of c is equal to 0. F prime of c is equal to 0 from 60 to 120. And that, yes, there must be. I'm not going to write all of this out. It's just MVT. And so you could say the average rate of change is 0. And so there must be a variable or a value such that the average rate of change is 0. Or such that the rate of change at the instant is 0, because f is a differentiable function. So basically writing out that will get you the point for part B. All right, part C asks for the average flow of gasoline. And so the the average rate of flow of gasoline. Let's see, wait. Average rate of flow of gasoline. Okay. So we're going to go from 0 to 150. So that is the average flow value. And so if this is the rate, we are going to integrate the rate and then we're going to immediately divide by the interval because that is going to be the average value. We're trying to find the average flow value. So we take this and multiply it by the interval. The average flow is the integral, or the average value is the integral over the interval. So that's going to be 150 minus 0. And then we're going to do of g of t dt. And so this is going to be 0.0959, it looks like, and then gallons per second is what I got. All right, let's look at part D. So using the model for G, find the value of G prime of 140. So you can just enter this into your calculator, say G prime of 140. And so that should be about negative 0.004909. And this is the derivative of the rate. So it's going to be with respect to time, so that's going to be in gallons per second per second. So I'm just going to put G per second squared. And so now it says interpret this. So at T equals 140 seconds, the rate of flow of gas is decreasing. And what is it decreasing at? It's decreasing at this rate, at the rate of 0.004909. So the reason why I don't have the negative here is because I said that the rate of flow of gas is decreasing. And so that already implies that it's negative. And so I'm going to just put units here per second per second. That's the entire first FRQ.